We're moving into my favorite topic, is thunderstorms. So we're going to talk about thunderstorms. It's a specific type of weather event. We've talked about lift. We've talked about circulations. Well, as part of a cold front and in a warm front sometimes, and even by themselves, thunderstorms form. So we need to understand a little bit about them because they're kind of an individual weather event. So I want to talk about conditions that favor it. So let's just talk about a basic thunderstorm. If you're outside in the summertime, did you ever watch a cumulus cloud go up? We've talked about air parcels. Well, air parcels are in that cumulus cloud. Maybe one big air parcel. And that cumulus cloud just goes to reach the towering stage. All the air is going up at that point in that air parcel. At some point, it reaches a level where some of the air begins to come back down, the mature stage. When that happens, you get a downdraft. Some of that cold, moist air, remember there's a lot of moisture going in there, evaporation's occurring, precipitation's occurring, it's cooling the air, it's a cooling process. So that's sinking, that's heavier. So you get that air coming back down to the ground, but you also have the warm air coming up. So you must, in order to maintain a circulation within a thunderstorm, you've got to have the warm air coming in and then the cold air coming down. At some point, if it's just one thunderstorm by itself, it's all going to go down. There'll be nothing left going up because the downdraft is going to hit the ground, spread out so much that it just blocks any of that warm air from coming up. But that is the cycle of a thunderstorm. And typically a thunderstorm lasts anywhere from 30 minutes to an hour, one thunderstorm. But we have different classifications for thunderstorms. We call them a single cell, multi-cell line, or supercell. Each one of them gets more and more severe, more danger to your health or to damage the property. So let's start with multi-cells. Multi-cells are characterized by a group of thunderstorms, each one in a different phase of its life cycle. The southernmost cell, because let's face it, most of the moisture around here and warm air comes from the south. So the southernmost cell usually is the one that begins to develop. And as it's moving east, northeast, begins to reach its mature stage, and eventually it'll be up here in the dissipation stage. And a new cell will have taken its place. Except that instead of the line being here, the line will be over here and eventually over here. But there's continually a new cell in motion. So the cells move to the northeast, the actual line moves to the east. And that is because of the new cell formation. These tend to have some severe weather with them. Maybe not a lot, depending on how they're structured, but it's the beginning of having severe weather. And you can get a whole bunch of thunderstorms at the same time. Conditions for thunderstorms, we obviously need in maritime tropical air, something to destabilize the atmosphere, we get lift. And usually there's something that's forcing the air to initially rise. Maybe it's convergence along a sea breeze, or in your all's case, Lake Erie. Maybe it's mountains. Whatever, up cold fronts, warm fronts. So solar heating drives it. So the most thunderstorms typically occur during late evening, when the warmest part of the day is. So here you can see a map of the thunderstorms in the United States, and notice the maximum down over Florida. Think about it. Florida has maritime tropical air on both sides of it, really. The Gulf of Mexico is quite warm. The Atlantic Ocean is quite warm. And you have two sea breezes. You have an Atlantic coast sea breeze and the Gulf of Mexico sea breeze. They converge. If you're out down in Florida sometime, you can actually watch the line of thunderstorms that develops along these sea breezes, moving westward and eastward. And depending on which side is more powerful, is where across the state those thunderstorms are going to be that day. Severe thunderstorms, the definition is by the Weather Service, and the idea is to put a severe thunderstorm as something that's going to cause damage. Is winds got to be stronger than 58 miles an hour, and the hail has got to be at least 1 inch in diameter. And there also may be flash flooding with thunderstorms. The higher the anvil top, the more likely of any of these severe weather events occurring. So what helps this thunderstorm to continue to grow? I was told you that it needed to keep having moisture, warm, moist air inflow into it. So in order to do that, you need wind shear. And that means changes of wind with direction, either direction and speed with altitude. So that helps to maintain the updraft in a vertical way, keeps it from mixing and moving over into the downdraft too much, and it allows the warm, moist, humid air to flow up into it to sustain it. So that these are longer lived. The more wind shear, the better the chance for longer lived thunderstorms. And we basically look at fine wind shear, say if you had a straight line, the winds were all from the same direction, but the winds change speeds by 40 knots over the first 6,000 to 10,000 feet in the atmosphere. That would be enough to have to trigger severe weather. Here is a typical synoptic weather pattern for the Great Plains that causes tremendous thunderstorms. And we get these, they can be shifted in different parts down in the south, and I actually talked about this high probabilities we had of severe the other day. But notice there's lots of tropical moisture coming up out of the Gulf of Mexico. You have a high tropospheric jet. Notice how the winds, one are southerly, one are out of the southwest. You have the cold continental polar air coming in on the northwestern side. You have a cold front providing lift or even a dry line. So this is a classic with a very strong low up over probably Nebraska. So this is the classic for the Great Plains to have severe weather. One of the interesting things out in the Midwest, a lot of times, you want to get the atmosphere as most unstable as you can. In order to do that, you got to heat the bottom of the atmosphere. Well, remember, the atmosphere begins to mix once we get some instability down the lowest part of the atmosphere, it's going to tend to push the air upwards. You don't want it to go too far if you want to keep clouds from forming and get more sunshine. So if you have a stable layer, say around 5,000 feet up, it's not going to let that many clouds form, and it's going to allow the temperature to rise. But then when you break that stable layer, you have all that pent-up energy down below it, all that heating that has happened, and it's going to really take off, and that's when you get your most severe thunderstorms many times. Lightning is an interesting facet of thunderstorms, and it's weird. Grapple, which is like a hail, it's very small, very wet ice crystals. They become negatively charged when the temperature is less than 5 degrees Fahrenheit. However, ice crystals, which are just pure ice, become positively charged. So there's a separation of charges, a negative charge and a positive charge. But guess what? When the temperature is greater than 5 degrees, they flip. So that's what makes it so confusing. So if you get a grapple pushed up into the clouds in the updraft, you get below -5, go 5 degrees Fahrenheit, it becomes negative. However, if it sinks back down, it becomes positive again. So you actually set up a charge between the two, and that's where your lightning strikes. And you can see it here in the diagram. Downdrafts are really, really nasty for aircraft because aircraft, the winds into the wings provide lift. So the more wind coming in towards the wing, the better the lift. The less wind, the worse the lift. So if you were an aircraft pilot coming into a downdraft, in a microburst, we'll say, it's a very small area, maybe only covering part of the glide path into the runway, and you hit headwinds, your plane would want to go up, so it would want to go above the glide path. So you're going to want to correct that, right? Pushing the nose down of the plane. But now you come out of it, and all of a sudden the winds are behind you, and that's when it becomes very dangerous because that's when you got to keep the plane from hitting the ground too soon. Derechos are another type of long-lived wind events that cover miles and miles. So I wanted to show you a derecho quick before we go on here. Here is a derecho that occurred back in 2012. It actually developed up over Iowa and then moved southeast. The thunderstorms literally developed early in the morning over Iowa and gradually move southeast. And you can actually see these on this line right here. And these are some of the wind reports. 91 mile an hour coming through Indiana. In Ohio, 81 mile an hour there. 84 miles per hour up here. They got into West Virginia. They were still doing 70 mile an hour. And they still did it all the way to the coast. Matter of fact, I had damage at my house. I had a tree blown down with this wind event. So this one, duratios go over a lot of distance with straight line wind. And you can actually see here the clouds. They'll move out here in a second. But it shows you them coming eastward, growing, move, forming, continuous, move right on down through. So it's an amazing event, a duratio. Let's move on to this a second here again. And here is, I just show the clouds, how they form and get like a bow echo to them at the time. And you can see here some of the different reports of different events. This was 2018. Another one occurred. Flash floods, think about it. There's lots of moisture coming into thunderstorms. So there's going to be lots of precipitation with them. So with that, many of the urban areas cannot hold a lot of very heavy rain. The idea, urban planners supposedly plan for a 100-year flood. Some of them only plan for a 50-year flood. Well, when you get into a thunderstorm, what you're getting is tremendous rainfalls, maybe even 3-4 inches in an hour. Many of that is towards the end of the upper range of a 100-year flooding event. So that many times they can't, the asphalt, all the water that's constantly running off into the drainage ditches, and they just get filled up to where they can't handle it anymore, and it backs up. I was in a conference at Tucson. Tucson doesn't get a lot of rain, but that day they got about an inch of rain, a very heavy thunderstorm in about an hour, and there was flooding all over the streets there where the water was trying to make it. And flash flooding is extremely dangerous. If you're in it, the fastest way to get out of it is to go straight up. I lost a friend in the Big Thompson Canyon flood way back in 1976. What they did was try to drive out. And when they got caught by the flood, instead of going up, they tried to drive through, continue driving, and the car got washed down in the canyon and everybody drowned. Hail's another hazard for severe weather. And you can see here, think about it with hail shaft. They form in the upper part where the air keeps going up, right where the edge, where the downdraft and updraft are. You get these, some of the moisture gets brought back up in the updraft time and time again, and gradually increases the ice size in that particle to where they become significant, and gradually they're going to come back down to the ground. Dual pole radar is great at picking out hail shafts. Tornadoes, they're extremely powerful. Notice the wall cloud here, that it's well below the level of the surrounding cloud. Why is that? Because it brought in cool, rain-cooled air from the downdraft, got wrapped up back into the circulation, so the clouds could condense much lower, and they really spin. When you see flat clouds that are well below what looks like a towering cumulus cloud, watch out. And tornadoes are extremely strong. There's two areas that are predominant for them. One is called Tornado Alley. Basically, it goes from northern Texas up through Nebraska. And there's a secondary area, which has become more prominent lately, it seems like. Mississippi, Alabama, Florida, Southeast, Dixie Alley. Both of them typically get a number of major tornadoes. And here, this last few weeks, Dixie Alley has gotten a lot. You can see the percentage per area and different areas that get tornadoes. And here's how frequently the major ones are. This was the Joplin tornado. It was an EF5 tornado that went through downtown Joplin. It brought up a very interesting question for forecasters. It was well forecast. Matter of fact, it was extremely well forecast. There was literally over an hour lead time for residents in Joplin when that tornado was going to occur. Some of them assumed, because there was such a long lead time from the time they first heard the warning, that the tornado obviously missed their area, when in reality it was still moving towards them. Here you can see the circulation, the mesoscale circulation, large hail, many times accompanying that, because there's tremendous updraft in that part of the storm. Updrafts can exceed 150 miles per hour and last for a long time. Supercells have very strong wind shear, so they continue to have great input of warm moisture into it. And with that, you can see that flat wall cloud, very flat, and then the tornado slowly dipping down and out of it. And here you can actually see it on radar. So I just want one last thing to quickly show you with this. Last year, you all had in fall a major, almost like a tornado, a strong wind event at Mount Vernon. And there were some severe thunderstorm reports. Obviously, you've had 2 of them that day. I just wanted to just quick peek at that. And really, you don't get a whole lot here. But you can actually see a line of clouds just to your right along or near you with that. And if you were to look at that, there's an actual front there. But we talk about frontogenesis. So let's see about frontogenesis there. I want to retrieve some data again. Frontogenesis causes uplift. It causes convergence. Wow. Very strong frontogenesis developed across Ohio right before you got your severe weather. Wasn't exactly forecast very well, but it did occur there. So that generated the lift for this. And if you want to look at instability with this, you can go down here a little bit. We'll take a look at Cape, which is just a measure of instability at that time. And you can see here's 4,000 joules of Cape, which is a ridiculously high number. So there were literally over 2,000 to 3,000 joules of Cape. Anything over 1,000 to 1,500 is significant. And when you're getting up into these numbers, it's no wonder with that kind of convergence and uplift being pushed in there, that much joules of energy, everything was coming together to give a good line of thunderstorms through your area. So that's why you got that extreme event there. All you can see related right to what you're learning this week. So hope you got something from all this, and if you have any questions, let me know.